Hello students, we're going to start our lesson. It's Unit 1. These are the notes that we'll be using for our class. And we begin in Chapter 2. Chapter 2 basically states the following. A categorical frequency distribution, we're going to be using that to organize data. In this case, categorical or qualitative data. These types of data values are typically nominal and not quantitative in nature. Examples of categorical data would be hair color, gender, class standing, zip code, major, favorite football team, etc. These are non-numerical data values. So basically, when we collect our data, we want to organize it to put it into a table. These tables are called frequency distributions. So we have an example. It says, assume that a local lepidopterist, those are people that study butterflies, has a way station that she cultivated near the foothills of Azusa. This past June, she made the following observations of the butterfly types. We want to construct a categorical frequency distribution. So let's look at our process. Our table will have 4 columns. So we have the class column. That's where we put each of the categories down. So we have our, this case, there are 6 different types of butterflies: the cabbage butterfly, fiery skipper, monarch, mourning cloak, painted lady, and swallowtail. In the next column, we tally the data. That means as we check off each data value, we place a mark. So for swallowtail, you would put a mark for swallowtail. Painted lady, place a mark for painted lady, and so on, until you tally up all the data values. Now the frequency column, that's found by just adding up the tally marks. So there's 5 cabbage butterflies, there's 9 fiery skippers, 8 monarchs, 4 mourning cloaks, 6 painted ladies, and 10 swallowtails. And then finally, the last column will be the percentage of each butterfly type. So what we need to do is we have to find the sum of all the butterflies. How many butterflies were surveyed at the weigh station? That's going to give us our N. And it looks like there's 42 butterflies. Let's just double check that. So we have 1, 2, 3, 4, 5, 6, 7 times 6, so 42 butterflies. So let's say we want to calculate the first percent. So what we do is we take the frequency of 5, we divide that by the total number of butterflies, 42, we get a decimal. So 5, use your calculator, you get 5 divided by 42, that is 0.1190, and we'll just say up to 476. So what we want to do is we want to convert this to a percent. So to convert this to a percent, and we're just going to convert it to a whole percent, we move the decimal 2 spaces to the right. So it's 11.90476, and then we write down the percent sign. But we will round this to a whole percent. So since 9 next to this 1 is above 5, we add 1 to 11, and we drop the decimal part, so it's 12%. And you can repeat that process for the other percents. So I have a problem for you to try. In this problem, we have different types of flowers. Those are the categories. you will go ahead and construct a categorical frequency distribution for these problems. The answer is at the very end of this document, so you can check your answer at the very end of the document. We're now going to move on to what's called a group frequency distribution. So a group frequency distribution is used when the data is quantitative and the range is large. So we're presented with some data values that represent the ages of family members, and it says group the data set into 5 classes. So step 1, we have to compute the range. It's the highest value minus the lowest value. So we take 95 minus 9, 86. That's the range. We always start at this step. Step 2, we compute the class width. The class width is the range divided by the number of classes. Always round upwards to the nearest whole number, odd whole number. So we take 86 and we divide by 5, because remember, they want 5 classes. That's 17.2, but for the class width, we round upwards. We bypass 18. We want to round to an odd whole number. Let me just write that down here too, an odd whole number. Thus, the class width is 19. Step 3, we write down the headings of each column for the frequency distribution. Class, class boundaries, tally, and frequency. Step 4, determine the lower class limit. So our first step in building our classes is to determine the lower class limits. We always start with the lowest value. So for our class, we will begin with the lowest value. In this case, the lowest value is 9. And then we will just add 19 to 9. That's going to give us 28. You add 19 to 28 to get 47, and then just repeat this process until you have 5 lower limits. Now we have to determine the upper limits. To determine the upper limits, you take the second lower limit, in this case 28, and subtract 1 from it, so that's 27. That's going to be our starting point, and remember, each of these classes are separated by the class width, which is, in this example, is 19. So just add 19 to 27, you get 46. Add 19 to 46 to get 65. Add 19 to 65 to get 84, and then add 19 to 84 to get 103. Now we have our second column consists of what are called the class boundaries. In the future, we're going to have to graph these frequency distributions. So we have to close the gaps between the classes. So there's some gaps between 27 and 28, 46 and 47. To do this, we will subtract 0.5 from the lower limits and add 0.5 to the upper limits. So subtract 0.5 from 9, that gives us 8.5. Add 0.5 to 27, that gives us 27.5. Subtract 0.5 from 28, 27.5, add 0.5 to 46, 46.5, and just repeat for all the other class limits. Now our next step is we tally the data. So we have to determine where each of these, which class each of these data values falls into. 23, well, 23 will fall in the first class, so you would put a tally mark there. 45, that would fall in the second class, so you put a tally mark. And you repeat that for all the other data values, and we end up with the following tally. So you can double check that if you desire. And then finally, we just write down our frequency. So the frequency, once again, you just add up all the tally marks. So there's 7 data values in the first class, 5 data values in the second class, and 4 data values in each of the last 3 classes. That is the grouped frequency distribution. So at this stage, you can pause the video and you can go ahead and work out this example here, which is the question is asking to use this data set to form a group frequency distribution using 7 classes. The answer is at the end of the document. All right, so moving on, we now talk about what's called the cumulative frequency. The cumulative frequency, and this is going to be is defined as a running total of frequencies. And so we will use these cumulative frequencies to find what's called the cumulative frequency distribution. So let me just write that here. So to construct a cumulative frequency distribution. So just think of the cumulative frequency as the sum of all the frequencies that precede a given value. In this case, the value will be a class boundary limit. And this type of distribution only has 2 columns. So we have a less than class boundary limit. I just put class, you could put less than, or you can write class boundary limit as the heading of this column. It's up to you. And then you write down your cumulative frequencies. So here we have the less than class boundary limits, cumulative frequencies. What I do is I just list each of the class boundaries. I list all of the lower class boundary limits, and then I cap it off, because all of these limits on this side repeat. I cap it off with the largest class boundary limits. Now, what we're doing is we're computing a running total of all the frequencies that precede these limits. So 40.5, there are no frequencies that come before it. So for this type of distribution, we always start with 0. Okay. And then we go to 9.5. Well, 9.5, the value that precedes it is 3, so that's going to be 3. 14.5, there's 2 values that precede it, 3 and 4, so you add them together, that's 7. 19.5, there's 3 values that precede it, so 3 plus 4 plus 10, 17. 24.5, there's 4 values that precede it, 17 plus 14, that's going to give us 31. And then for 24.5, we add all of these values, so 5 plus 31 is 36. And then finally, we add up the entire column, that's going to give us 38. This is a cumulative frequency distribution. And it's used to graph a specific type of graph called the ogive, and we'll learn more about that in section 2.2. And then once again, you can hit the pause, and there's an example for you to work on. As I mentioned before, the answer is at the end of the document. And so that will conclude 2.1. Now we move on to section 2.2, where we actually examine graphs. So we're going to look at graphs. We'll just say graphs. There's 3 types in this section that we're going to examine. The first is called a histogram. So a histogram is a graph that uses bars to represent the frequencies of classes in a frequency distribution. So we have this distribution here, and what we want to do is construct the histogram. Well, the first step in constructing this histogram is we have to write down our axes. We have an x-axis that's always horizontal and a y-axis that's always vertical. And we place the class boundary limits on the x-axis. So we're going to list all of the class boundary limits from 8.5 to 103.5 across the x-axis. On the left side, we write down our frequencies. In this case, our maximum is 7. We'll just go by, and you have to determine the units on your own if you're drawing the graph yourself. So we'll go by units of 1. And then for each pair of class boundary limits, we draw a vertical bar with a height corresponding to the frequency. And we'll just say of the class, of the limits. Okay, so let's take a look. So we're going to think of these as pairs. So the pairs will make up the width of your rectangle. So 8.5 to 27.5. 8.5 to 27.5. 7 is the frequency, so you just draw a bar with height up to 7. Now we construct the next bar. That has a height of 5, and that's going to be for the pairs of 27.5 and 46.5. You draw the histogram, and you just repeat for all the other pairs. And this right here is your histogram. You want to ensure that the bars touch. So for a histogram, the bars must touch. Okay, so if you just have a regular bar graph, the bars do not have to touch, but in the histogram it is required that the bars touch. So our next type of graph is for this section is called a frequency polygon. So a frequency polygon is a line graph that connects the frequencies of each class at the midpoints of the classes. Okay, so what we have to do first, step 1, is we have to compute the midpoint of each class using this formula. So x sub m, that's going to be what the symbol we use for midpoints. You take your lower limit plus the upper limit, divide by 2. And that's how we compute the midpoints. So what I'm going to do is we have the midpoints here, so let's just kind of run through it. So 9 plus 27, that's 36, and then divide 36 by 2, you get 18. That's our starting point. Now you could just repeat that pattern using the formula, but we can also use the class width. Well, the class width is 19, so you just add 19 to 18. That's going to give us 37. That's the second midpoint. Add 19 to 37, we get 56. That's the third midpoint. Add 19 again, 75, because remember 19 is the class width, so you're just adding the class width. And then finally 19 plus 75 is 94. So just to kind of run through that process one more time, we calculate the first midpoint, add 9 and 27, divide by 2, you get 18, and then just add whatever the class width is. And that will generate all the other midpoints. So now we construct our axes. We will place the midpoints on the x-axis and the frequencies on the y-axis. Next, we plot points using the midpoints as your x-coordinates and the frequencies as the y-coordinates. So 18, that will be your x value, y will be 7. So at 18, we go up 7 units and make a dot. And then for 37, we go up 5 units and you plot your point, and then for all the others we plot 4. Now the next step, you connect all the points with straight lines. And then finally, the very last step is we have to anchor the graph to the x-axis in the location where hypothetical midpoints would be located. So if you recall, all the midpoints are separated by the class width, which in this example is 19. So you would subtract 19 from 18 to get -1. You would add 94 to 19 to get 113, and then anchor the first and last points to those locations. This is the frequency polygon. And then finally, there's one last graph for this section. It's the ogive. The ogive represents the cumulative frequency distribution. So this right here is our cumulative frequency distribution for our regular frequency distribution up here. We're going to go ahead and construct the ogive. The ogive is a line graph that only anchors on one side. So let's take a look. So starting with step 1, we place the class boundaries on the x-axis, cumulative frequencies on the y-axis. In this case, our maximum is 24, so we're just going to go by units of 5. You plot your points. Okay, so we're going to plot the points. So you plot your points for the cumulative frequency distribution. So at 8.5 it's 0, and so on. You just plot your points. And then finally, you just connect the points with straight lines. And that's how we graph the ogive. It's a graph, once again, that's used to represent the cumulative frequency distribution. And finally, we have a few problems for you to try. Once again, the answers, as you'll check, are at the bottom. Here are the answers of our document. So work those problems out, and we have just covered Unit 1, which relates to Section 2.1 and 2.2 in our book.